We see this sign every day. The red octagon is a universal signal to stop, chosen because its distinct shape and symmetry make it recognizable even when the paint is completely worn or the words are obscured. Moving into the mathematical definition, a regular octagon is defined by 8 congruent sides and angles. Within this framework, we can identify 8 vertices and 8 distinct lines of reflectional symmetry, where the shape mirrors itself perfectly across the center. There is hidden complexity inside. Using the diagonal formula, n times n minus 3 divided by 2, we find exactly 20 intersecting diagonal lines connecting those vertices across the interior. An everyday object operates on a quantifiable structural logic. Once we identify the rules governing that structure, we can calculate its exact properties. This diagram shows a point tracing the perimeter. To make a complete loop, it must turn exactly 360 degrees. Divided across 8 equal turns, each exterior angle measures exactly 45 degrees. That 45-degree exterior turn forms a straight 180-degree line with the interior angle. Subtracting 45 leaves an interior angle of 135 degrees. We can deconstruct the shape further by drawing lines from the center point out to all 8 vertices. This divides the octagon into 8 identical isosceles triangles. Isolating one of those triangles, we drop a perpendicular line from the center to the base. This line is the apothem. It bisects the 45-degree central angle into 2 smaller 22.5-degree slices. With a right triangle established, we use trigonometry. The tangent of 22.5 degrees provides the length of the apothem relative to the length of the side. Calculating this single internal vertical line provides the specific height needed to solve for the total area of the entire shape. This diagram isolates a single triangle with a base of S and a height of A. Given that the total perimeter is P equals 8S, take a moment to deduce the total area formula from these pieces. The area of one triangle is 1/2 base times height. Multiply that by 8 and it simplifies to the total area formula, 1/2 the apothem times the perimeter. We can also prove this through subtraction. If we draw a square that encloses the octagon, we isolate 4 empty corners. These corners are 45, 45, 90 right triangles. Subtracting their area from the bounding square yields the exact same calculation as the triangle-based method. Mathematics is robust because it provides multiple logical paths. Building the area from the center triangles or subtracting from an external square leads to the same structural truth. This 3D printed caddy translates these abstract constraints into a physical object. Its design is dictated by the geometry of the octagon. It functions as a 5-piece puzzle, a removable central square and 4 outer pentagonal pieces connected by pivot hinges. When the center is removed, the hinged segments swing outward and lock into a square outline. This relies on rigid motion. Because the physical pieces rotate without stretching or shrinking, their individual dimensions are constant, and the total area is perfectly conserved. These rules, exterior angles of 45 degrees, interior angles of 135 degrees, and area preservation through rigid motion, define the shape's behavior. Mastering the geometric constraints of the octagon allows for these precise transformations, turning static principles into mechanical engineering.